In this lesson, we are going to talk about solving systems of nonlinear equations algebraically. Now, this is going to be 14.4, and a lot of this is going to be a recall of Algebra 1A. So the first thing I need for you to do is to remember the three cases of what can happen when systems are linear. So what I would like for you to do is pause this video, and when you pause it, I need you to solve all of these equations for y equals and graph it. Solve this one for y equals and graph it. Solve this one for y equals and graph it. Okay, so for this first one, I hope that you solved this one for y equals and you got 1/4 x plus 3. And this one was already solved for you. So when you graph it, the graph looks like this. You have this one coming up, this one coming up, and these two lines meet at 4, 4. Now, once you write down 4, 4, you know that it's got one solution because that's the one point of intersection. Now, that's the first case that can happen when solving systems by graphing. You can have one solution. Now, let's look at the second situation. I hope that you solved the bottom one for y equals and got a positive 5x plus 3, and the top one was a 5x minus 4. I also hope that you notice that 5x and 5x has the same coefficient of 5, which means they have the same slope. So if you look at graphs with the same slope, you notice that they are parallel lines. And parallel lines never touch, so therefore you have no solutions. So this is the second case that can happen with two lines. You can have no solutions because the lines never touch. Now, what was the key to knowing that before you graphed it? You had same slopes, but different intercepts. Now, for the third case, I hope that when you solved it for y, that you noticed that it was the same line. They look different here, but when you solve them, it is the same line. So when you graph it, you have a single line. Now, they're on top of one another. So this situation, since it is the same line, this is infinitely many solutions on this line. Remember, I do not want you to say all real numbers. All real numbers means everything on that graph. This is many, many, many solutions on this one line. So, recap, when solving linear systems, three situations can occur. One solution is one intersection point. Label it. Parallel lines are no solution. They never touch. Here, when it is the same line, here it's infinitely many solutions on that line. Well, chapter 14 has been bringing back everything and everything that we've studied so far. And here is the key word, nonlinear. These are all linear. So what we need to look at and kind of study and kind of just think about what happens when you have a system of nonlinear equations, okay, and what's going to be going on there. So here, a nonlinear system is two or more equations. At least one of them is not linear, okay, and they're happening at the same time. Now, we are going to do this graphically first to get us a good picture of what in the world is going on. So as you look at number 4, you will notice that number 4 is a linear equation and a quadratic equation. So the first thing we're going to do is we're going to look at the linear equation. So we've got y equals 2x plus 1. We have a slope of 2 and a y-intercept of 1. And you all know how to graph that. So let's come down to the graph. Let's graph 1. Go up 2 over 1. Keep doing that process to get a good picture of a line. We need to be neat while we're working these. So there's the first line. Now the second line, you're going to see the quadratic here, the x squared. So we're going to do a quadratic. And remember, you have 3 ways to graph this quadratic. This quadratic can be solved with standard form, intercept form, or vertex form. Now, this one is actually in vertex form. It may not look like it's in vertex form, but it is in vertex form. So this is what it would look like with vertex form, like that. And you could see that your vertex would be 0, 1. But let's say you forgot that and you didn't know that. So you would do negative b over 2a. And the b is 0. That's why it is in vertex form. And you get a 0 there. But when you plug 0 back in, you're going to get a 1. So here is the vertex. A is 1. So it's going to follow the 1, 3, 5 pattern. So once again, you know a lot about quadratics. So we're going to just use some shortcuts here. So the vertex is 0, 1. So we are going to graph that right there. It goes up 1 over 1, up 3 over 1. Go the opposite way to keep your symmetry. We are going to graph it. And something happened there when I graphed it. I actually hit 2 lattice points on the line. So we no longer maybe not have one solution. We actually have 2 solutions for this one. So 2 solutions happen with this linear and quadratic. The first solution is here. That is 0, 1. And the second solution happened here, which if we count that, it is 2, 1, 2, 3, 4, 5. So that is 2, 5. Now remember that we can always check these. You simply plug each point back into each system and it will check out that it is on both of them. So that is one case. 2 solutions can happen, and the reason why that can happen is that now we are dealing with a nonlinear graph. The curved graph can make that happen. Now let's look at question 5. We have a linear piece and an exponential piece. So let's see what happens for this one. For the linear graph, we have y equals x minus 1. We have a slope of 1, and we have a b of negative 1. So we can come down to the graph it. Once again, make all of your lattice points as we need to be very accurate. So there's the line. Now we need to do this exponential graph. Now remember, I know it is exponential because of the x right there as the power. So for exponential, there's really no tricks to this. We just need to make a table. Now remember, you can use your calculator to help you make the table. There's nothing wrong with that. But I'm just simply going to make a quick little table here. Try to get several points on there so I can look at it. So if I plug in a negative 1 here, 3 to the negative 1 is 1/3 minus 2. So what is 2 minus, or 1/3 minus 2? That is negative 1 2/3. Plug an easier one in, the 0 there. Well, that's just going to give me 1. So 1 minus 2 will give me negative 1. Plug another one in, 3 to the first power minus 2. That's going to give me 3 minus 2, which is 1. And plug 3 to the second power in, minus 2. That is going to give me 9 minus 2, which gives me 7. So you can see here it's growing, but it's going slow, and the minus 2 is going to shift the graph down 2. So we have growth with a shift. So now I go to negative 1, negative 1 2/3. So it's right here just above that 1 point. I have a 0, negative 1, which is a lattice point. I have a 1, 1, and I have a 2, 7, which runs off the graph. Now remember, this is the shift down, this -2, so it's never going to cross that -2. And it's going to come up, and it's going to look like that. So I've got a curve. But this time, I only hit one time, and that is going to be at this lattice point right here. So this one is going to have one solution. That solution is going to be 0, -1. And that is the next thing that can happen. So quadratic can touch 2 times. Exponential can actually touch 2 times if the line goes through the curve. But here is an example of when it can touch 1 time. Let's say the line ran through the vertex. That's a 1 touch. Here it's touching right there. So here is another situation that can happen. With a curved line, it can actually just touch 1 time. So if we look back over here, the line can go through the curve twice, or the line can go through the curve just 1 time. Now we have one last problem left with the graphing examples, and that is going to be number 6. Now on number 6, we are going to deal with the quadratic and an exponential. They're both nonlinear, so that both can happen. So we are going to start out with the quadratic first. And this time we have the quadratic in standard form. So if it is in standard form, our best bet is just to go ahead, calculate the vertex, and make a table. The only thing I know is it's going to go down. It's going to have the 1, 3, 5 pattern. So let's first start out with the vertex, -b over 2a. So I have -2 over 2 times -1. That is going to give me -2 over -2, which is 1. I'm going to plug 1 back in to calculate the other side of my vertex. So negative times a 1 is -1, plus 2 minus 2. So it looks like that our vertex that we're dealing with is a 1, -1. That is the vertex. Now, I can plot that vertex, 1, -1. I could do the 1, 3, 5 pattern, or I could go ahead and make the table. Now, there's nothing wrong with making the table. So you could put the 1 in the middle, 2, 3, and then on the other side, 0, -1. Now, your calculator is going to make that, quicker, but I'm just going to mental math it. If I stick 0 in, I'm just going to get left with a -2, and these will be -2. If I stick a 3 in, I'm going to get -9 plus 6, which is -3, minus 2 will be -5. So you could mental math it, you could put it in your table, or you could simply just find that vertex, and since the A is a -1, it's a -1, 3, 5 pattern. So whichever way you like to do it, we're going to go ahead and just graph our quadratic. It's a parabola upside down. So we finally got that first little piece completed right there. Now, the next thing we have to do is we need to do the exponential one. Once again, there's not really a trick to exponential. We just need to do an old-fashioned table. Remember to follow order of operations. So if we do a table, let's see here. If we put a 0 in, 2 times 5 to the 0 power, that is 2 times 1, which is 2. So this is 0, 2. If I put a 1 in, that is 2 times 5, which is 10. So you can see it's growing quick because 2 10 is going to be way up here. So now let's go back to the -1. 2 times 5 to the -1 is 2 times 1/5, which is 2/5. So -1, 2/5 is right here. So what's going on with this one is never crossing 0, and it's going up really fast. So that's what that looks like. Now, in this example, you can clearly see